In this video, I'm going to look at running a test of hypothesis about a population mean. And in the example in your notes, the question is whether or not the salinity of some canned shrimp, or the brine, is equal to 2.5 or whether it's different from 2.5. Now here in this file, Maturing Quality Reports, we've got the salinity of a number of cans of shrimp, and we want to run the test of hypothesis on this. Okay, so it was told to us in the problem that the standard deviation of all the salinity values of all the canned shrimp was 0.43, and because we know that, when we run the test of hypothesis, so basic statistics, we're going to be using the one sample Z. And note here the little blurb tells me, come back here, that it will determine whether the mean of a sample differs significantly from a specified value when the population standard deviation is known. Okay, so we click on this one sample Z, and it says here it's a one sample Z for the mean. Okay, we could give summarized data, but in this problem we have raw data. And the data we're interested in is the salinity of the solution. Minitab is prompting us for the standard deviation of the population, or in this case, standard deviation of this whole process of canned shrimp. That's known to be 0.43. We're going to perform a test of hypothesis. We want to know whether the brine of these shrimp is equal to what it should be, which is 2.5. And if we go to options, we're interested in whether it is not equal to 2.5, sorry, and that's the default that comes up. Now, when we do this problem, because this is a two-sided test, we are also going to be interested in the confidence interval, and we're making our decisions at an alpha value of 0.05, which means our level of confidence is 95, which is the default, so we leave that on. I'm going to say OK. And because I'm given raw data, it's always good practice to get a graph, and a box plot in this case would be a good graph to get. Okay, so there's the graph of my data, which, by the way, has a fair left skew to it, and this could pose a problem. In our case, it's not going to, because we know the true population standard deviation. But if we didn't, as we're going to see in chapter number 20, the fact that these data don't follow a normal distribution could be a bit of a headache for us. So right now I'm going to minimize this. I'm going to look at the output I get from Minitab. So first of all, it tells me what test it ran and what data it used. My test was that I assumed my average salinity level to be 2.5, and really what I want to know is it something different than 2.5, not equal to. I've given it the population standard deviation, and as I've pointed out in your notes, I've used the population standard deviation and not the standard deviation of the sample, which is what this 0.39 represents. Okay, there were 59 cans of shrimp. Of those 57 cans of shrimp, of those 57 cans, the average salinity was 2.6. Yeah, 2.6 is bigger than 2.5, but is it significantly bigger? That's the question. We come over here, Minitab has calculated for us the test statistic of 1.82, and it gives us the p-value. Now this p-value of 0.069, keep in mind because this is a two-tailed test, this represents the area under the curve to the right of a positive 1.82 plus the area under the curve to the left of negative 1.82. No need to multiply this by 2 because Minitab's already done it. Okay, I'm looking at this 0.069. The question to myself is this p-value smaller than my alpha value of 0.05? Clearly, 0.069 is a bigger number than 0.05. So what does that mean? Is P less than alpha? The answer is no. And anytime the answer to that question is no, we fail to reject the null hypothesis, which ultimately means that based on these data, it would appear that the salinity of these canned shrimp is not significantly different from 2.5. Is it exactly 2.5? No. I don't know that, but I do know that it's not significantly different. Now, I look at the, my p-value is simply telling me that my mean is somewhere in the order of 2.5. Usually we want to know, well, what range of values could the mean take on? And that's where the confidence interval comes into play. Minitab automatically calculates this for us. What can we say? We're 95% confident that the true salinity value for this whole process, for all the cans of shrimp that are produced in this plant, whatever it is, falls somewhere between 2.49 and 2.71. So could be as small as 2.49, could be as high as 2.7. When we look at this, the question we're kind of asking ourselves when we look at this interval is, does the value 2.5 fit in this interval? And the answer is yes, 2.5 is going to fit between 2.49 and 2.7. So are my canned shrimp, do they have an average salinity value that is significantly different from 2.5? No, they don't. And I'm looking at that from the basis of the fact that 2.5 actually fits in this interval. And this interval gives me some idea of where the actual average concentration will lie at, again, this time, a 95% level of confidence. So both my confidence interval and my p-value tell me that the salinity values are not significantly different from 2.5.